Let's take a look at changing the dimensions. So we want to describe the effect of each change on the area of the given figure if the height of the triangle is multiplied by 6. So first, the best thing to do is to actually find the area of the given triangle. If we make our list, area is what we're finding, base is 12 inches, and our height is 5 inches. To find the area, we have 1/2 base times height. So we can substitute in, and we get that the area is 30 square inches. Okay, so let's take a look at what if we were to multiply the height by 6. Our base stays the same. Our height we multiplied by 6, which gives us a height of 30 inches. So now we find the new area. And we get that our new area is 180 inches squared. So what relationship do you notice about the two areas? So if you were to actually compare them, 180 divided by 30 gives us 6. Well, if you remember, we multiplied by a scale factor of 6 units, or multiplied by a scale factor of 6. Down here, we also got a 6 when we compared the new area to the old area. So since we changed one dimension by a scale factor of 6, we just needed to multiply the original area by 6, and that would give us our new area. Let's look at another example. If the height of the rectangle is tripled, let's describe the effect of the area. Well, if we were to find the original area, we have a base of 7 feet and a height of 4 feet. Area is base times height. So we have 7 times 4, which is 28 square feet. So if we take into consideration what we just talked about, we have a scale factor of 3 since we are tripling. So what if we were to take that 28 feet and multiply it by 3? That would give us an area of 84 square feet. So let's actually triple the height and see what we get. So area is what we're finding. Base is staying 7 feet. Our height is now 3 times bigger, which is 12 feet. So if we were to write our formula, plug in our information, we do get a new area of 84 square feet. So you can either work it out each time, or you could remember that if we multiply by one scale factor, that's what we change it to. Let's take a look at a circle. Here we're multiplying the radius by 1/5. We want to find the new area of the circle. So let's think about what we have. Area is what we're finding. The radius we're given is 10 centimeters. So if we use our formula, area equals pi r squared, we get an area of 100 pi square centimeters. So if we think about what we've talked about in the previous two questions, we should be able to take this area and multiply by 1/5 since that's our scale factor. If we do that, we get an area of 20 pi square feet. But let's check our work to make sure that we did it correctly. So now, area is what we're finding. The radius, we're multiplying the radius by 1/5, which gives us a radius of 2 centimeters. So if we were to plug into our formula, we get an area of 4 pi square feet. Those numbers do not match up. So can you think of why the answers don't match up? Pause the video now to see if you can figure out the problem. Well, let's think about this. How many radii do we have in our formula? We are squaring the radius, which means we actually have 2 radii. So if we have 2 radii, we have to use that scale factor twice. So we could still take this 100 pi centimeters, multiply by 1 radius, and that would give us an answer of 4 pi feet squared. So you need to pay attention to how many of the dimensions are changing. For every dimension that's changing, you need to multiply by that scale factor. Let's take a look at another example. So here we're given the diagonal SU of a kite with those vertices is multiplied by 1/3. What scale factor are the perimeter and area changing? So if you remember, perimeter you could think of as one dimension because our answer are just in units. So the perimeter is changing by 1/3. The area is 2 dimensions, so the area is now changing twice, so we need to square this scale factor just like we would with our units. So our area is changing by a scale factor of 1/9. So it could be as simple as that. If you were given the original perimeter, multiply it by 1/3 and you now have your new perimeter. If you were given the original area, you would multiply that by 1/9 and you would have the new area, which is exactly what I want you to do for class. What are the new perimeter and area? Which means you're going to have to go back and find the original perimeter and areas of this kite. Multiply the perimeter by 1/3, multiply the area by 1/9, and then check to make sure that you did your work correctly by using your new dimensions and substituting in for perimeter and area. This will be due on Wednesday or Thursday in class. Let's take a look at another one. Here, we're given a circle has a circumference of 32 pi inches. If the area is multiplied by 4, what happens to the radius? Well, we could show this by using our formulas. We're given a circumference. We can find the radius. So circumference is 2 pi r, and I chose radius because we are dealing with area, and area does not use the diameter. So now if we substitute in, we can solve for r. And we get that the radius is 32 inches. Oh, I'm sorry. How about we divide that by 2 and we get a radius of 16 inches. So now we can find our area. We get an area of 256 pi square inches, remembering that this is the exact answer, which is easier to work with. But now we are told that this area is multiplied by 4, which gives us a new area of 1024 pi square inches. So now let's solve for the radius and compare our original radius to the new one. So if our area is 1024 square inches, what is the radius? Do not forget to write your pi since it is a part of the answer. So when we divide both sides by pi, we have 1024 equals r squared, and to get r by himself, we have to take the square root. We get that the radius is 32 inches. So now, what do you notice about the two radii? The original radius was 16 inches. The new radius is 32 inches. But we multiplied the area by 4. So if the area of a circle is 4 times bigger, remember with radius we had 2 of them. So our scale factor really ended up being 2. So we can take the original radius times 2 to give us the new radius. So you have to keep in mind which parts of the equation are you given. Are you given area? Are you given perimeter? Are you given the circumference? And how many scale factors you would need. So now it's your turn to try one. An equilateral triangle has a perimeter of 21 meters. If the area is multiplied by 1/2, what happens to the side length? So for class on Wednesday or Thursday, I want you to have this answer written. It will be a grade. Both of these questions will be checked, and it'll just be a completion. Do you have it or not? If you have any questions, please feel free to come in and talk to me. Good luck, and I'll see you in class.